fill this in, that would be my x-axis. So each point on your original y equals x is going to be reflected over the x-axis. And in geometry, you talked about a line of reflection, or sometimes it's called a line of symmetry. So the line of symmetry is that x-axis. So every point just gets flipped over that line of symmetry. Next, what happens when we start to adjust the y-intercept? So f of x plus c is a blank shift c units if c is positive. So let's see what happens when c is positive. So down here we have a graph x plus c, and then I'm adjusting my c. So if I start with c at 0, we can see that it's just going to be the exact same as the y equals x. But as c becomes positive, you can start to see, where is my graph going? Is it going up or is it going down as I make c positive? So what do you think? Is it going up or is it going down? It's going up. So I would go into here as c is positive. It's going to be a vertical shift. I'm just going to abbreviate vertical. C units up if it's positive. And if I make c negative, so if I make that y-intercept negative, we can start to see, where is that moving my graph. So if c is negative, that is going to shift it vertically down if c is negative. Okay, so we can start to see as we add, we're going up. If c is positive, if c is negative, we start to see that graph going down. And we've seen that as we've worked with the linear equations, but we're going to start applying this to other functions, quadratics, cubics, so the others that we've kind of started to introduce, and the same type of patterns are going to happen. So we're just kind of looking for these patterns. Lastly, what happens when I adjust the slope? So here I have y equals mx, so that multiplier in front of my x variable, what's going to happen as I increase that? So now I've got a blue line here that's exactly the same as my red line, y equals x. But as I start to increase my m, what is going to start to happen to that line? Is it starting to get steeper or is it starting to get flatter? Well, it is starting to get steeper. So as I increase that slope, I'm starting to see that it's increasing the steepness of my line. So heading back to my notes, c times my variable, or I'm using m times x, is a vertical stretch. So stretch is the word that's used as that line becomes steeper by a factor of c if c is greater than 1. So as c is greater than 1, or in most areas, when we have the m, as m is greater than 1, we start to see that graph is going to start to stretch. And then secondly, when does it start to do what's called a compression? Well, let me go grab that c again. So here, if I'm right at 1, that's exactly the same. 1, that's exactly the same as my parent function. As I start to go below 1, between 0 and 1, I start to see my graph flatten out. So any slope that's between 0 and 1 is going to start to flatten out. So here, I'm going to say when c is between 0 and 1, I'm going to start to see my graph flatten out. So we've practiced graphing linear equations, and I encourage you, when you get to problems like A, B, C, and D here in example 4, go to your schedule. You can click on that link to Desmos. It's a free app on your phone as well if you'd like to download an app there. And you can use that to kind of investigate these linear equations. So we've graphed example 4, similar problems like that in example 4 back in day 1. So we are going to move on to example 5. We'll finish up with example 5. Horizontal and vertical lines. So horizontal and vertical lines are when only one variable is used in a linear equation. So here we have y equals b is a linear function whose graph is horizontal with a slope of 0. And y equals b, whenever you have a y equals, that means all your y coordinates are the same. So whatever y is equal to, that's telling you that's what your y coordinate is of your function. And then x equals b is going to be a vertical line with an undefined slope. And here, all your x coordinates are the same. Okay. So going down to take a look at graphing one of these, y equals 5. Well, y equals 5 is where all y coordinates of your points are going to equal to 5. So I'm just going to remind us of that. Y coordinates are all equal to 5. So it doesn't matter what the x coordinate is. So if I have an x coordinate of 0, which would be right on the y-axis, 5, y equals 5 is right here. X coordinate of 2, 5 would be right here. 4, 5, whatever the case is, all your y coordinates are equal to 5. That's going to produce a horizontal line. So there would be the graph of y equals 5. Heading to x equals 2. So wherever x equals 2, that would be like the point 2, 0, 2, 2, 2, 4. Whatever the case is, as long as all your x coordinates are 2, that's going to produce a vertical line. So again, this is going to be where all my x coordinates are equal to 2. And then example 6 is also going to look at a problem that we did in day 1. And it's also one that if you want to play around with Desmos, you can use Desmos to graph that out. So I really want to encourage you to use that program Desmos to kind of get a feel. Even with these horizontal verticals, you can put those in and then just kind of get a feel for what type of function is produced depending on what kind of picture is produced, depending on what your function looks like. So that will finish up lesson 34. So now just taking a peek back at Friday's assignment. So looking back at Friday's assignment, in this class, one person finished the assignment on Friday. So let's make sure that now that we're getting towards the end of the semester, let's finish strong. So we've got one person that finished day 1, and then day 2, nobody has finished it yet because it just got entered this morning. But make sure that we're finishing the semester strong. And if you need help, some of you are emailing me screenshots. That works well. This morning I responded to a couple. So check your email if you emailed me a screenshot of a problem so that I can kind of point you in the right direction and help you out. But it's really important here. We got 2 weeks left in the semester. Let's finish strong and keep up with our current work. But at the same time, also look at trying to get caught up on anything that is also late work or stuff that we haven't completed yet. But if you are ready to break off to work on your own, you can go ahead and do that. I will stick around until 8:10 to help out, but the rest of the time is yours to work on lesson 34, day 1 and day 2. And have a great day if I don't see you, and we'll see you tomorrow morning. Thanks, you too. Yes. The example 6 is just going to be just another graphing example. So it's very similar to day